This is the combined spectral problem for group 7. The proposed molecular formula is C9H12. Starting off with the IR spectrum. From this, we can identify this bond, which is at the 3000 mark. The carbon-hydrogen bond indicates an sp2 carbon-hydrogen bond because of the range it is in. And we can also see on this spectrum the area here indicates a carbon-carbon bond. So these are the two types of bonds. We also need to look at what's not here. Here we're looking at the bonding angle, or the bending angle, I'm sorry. Next, we move on to the 13C spectrum. So from this, we're looking at how many unique carbons. So we have 6 signals, so we're looking at 6 unique carbons. Because we have 9 carbons, we may be looking at some symmetry. The other thing to kind of consider just when looking at this, the C9H12 shows that we have a hydrogen deficiency index. So we're missing 4 pairs. So what we might be looking at is double bonds or rings. Double bonds or a ring. So this indicates 6 unique carbons. The kind of where I like to start is by dividing it downfield and upfield. So over here we're looking at the sp2 carbons, the sp2, and over here we're looking at the sp3. And the signal down here, because of where it is, it's under 20, we're looking at ACH3. So then I kind of move into, or let me go back and do the tables for these. So the first table we're looking at, we have C9H12. Okay, so the frequencies we have are about 1500 and about 3000. So the functional groups we're looking at in the 1500 is a single bonded carbon to carbon, and in the 3000 range we're looking at sp2 to carbon to hydrogen. So then into the 13C, we have chemical shift of 15, which indicates the sp3 carbon bonding environment. We have a chemical shift of 25, which indicates the same thing. Oh. We have 39. Oh, goodness me. Which also indicates an sp3. And then further downfield, we have 125, 129, and 141, all indicating sp2. So then a lot of the information we're going to get is from this. This is the 1H spectrum. So the first thing we want to look at is shift, which is down here. So we're going to see the shift of 0 to 5 is generally going to be a hydrogen attached to an sp3 carbon. And then we're going to see the 5 to 10 range is going to be a hydrogen attached to an sp2. And then in the middle, or kind of not in the middle, in the 2 to 3 range, we're going to, okay, there we go. In the 2 to 3 range, we're going to see the sp connectivity. Okay, so starting with that, so that kind of gives us what the hydrogen should be attached to. The integration values are given, so we have 5H here, 2H, 2H, 3H. The multiplicity, looking at how many neighboring carbons we're going to have. So right here we have a triplet, so we're going to have 2 neighboring carbons, two neighboring hydrogens, 2 neighboring protons. Here we have a septet, so we're going to have 6 neighboring carbons. And right here we have another triplet, so we're going to have 2 neighboring carbons. And the final one is going to be a singlet. The interesting thing about this one is it's also in the aromatic proton region. So that indicates to us that we should have a ring. So moving into the degrees of unsaturation. So a C9H12 alkane should have a total, can have, if completely saturated, 20 hydrogens, and on this we only have 12. So we're going to take that, 20 minus 12 divided by 2 means we've got 4 degrees of unsaturation. And the degrees of unsaturation indicates a ring or a double bond. So we can keep in mind that we have 4. So looking at the table, the chemical shifts that we have for the 1H, we have chemical shift of about 1, and the integration on that is 3H. It's a triplet. And the interpretation on that is that we're going to have a CH and he's going to be bonded to that right there. Chemical shift of about 1.7. That is we have 2 of those for integration. And that one is our septet. So that indicates that we have our hydrogen in this one's going to be bonded to CH3. There's actually going to be 2 of those. We have chemical shift of 2.6, about, and that is we have 2 of those, 2 hydrogens in that range, and that's our other triplet. It's going to be similar to the other one, CH bonded to CH. And then we have 7.3, and that is our aromatic ring region. We have 5 of those. And that's our singlet. And that's where we're gonna see this. Our CH3 is gonna be bonded to this. Okay, so the proposed structure for this is a ring. And this is going to have 2 CH3s off of it. So to kind of to check our work, so the degrees of unsaturation indicate that we have a ring. When we're looking at the multiplicity and integration, so we're looking at 3, so the CHs that are